Now we are going to discuss about electric potential. An electric potential is the amount of work needed to move a unit of charge from reference point to a specific point inside the field without producing an acceleration. Now, or you can say simply, a work is done when the test charge is moved against the electric field. This is a charge Q. The flux will be radiating in all the directions, and you have the test charge. The test charge is Qt. Now the test charge is moving against the field, that is called as work done. Here Q is a charge and Qt is the test charge. The direction in which the movement has taken place is denoted by unit vector. According to the Coulomb's law, F equal to Q1 into Q2 divided by 4 pi epsilon naught into epsilon r into r squared. Here we have two charges, one is Q, next one is Qt. Therefore F equal to Q into Qt divided by 4 pi epsilon naught into epsilon r into r squared into ar vector. Now this value is called as E. Therefore F is equal to E into Q. Now the change in work done, dW equal to minus F into dl, which is equal to minus, what is this F value? E into Q. So E into Q into dl. Now you want to find out the work done. Work done W equal to minus integral A to B Q into E into dl. That means we are just simply applying the integral on both sides. 1 volt equal to 1 joule per 1 coulomb. The potential difference between the point A and B, we want to find it. Here voltage, that is V equal to work done by charge, which is equal to, what is this W? W equal to minus integral A to QE into dl. That is this value, this is the Q. Now this Q and this Q is going to get cancelled. V equal to minus integral A to B E into dl. Now substitute the E value here. Therefore E equal to Q divided by 4 pi epsilon naught into epsilon r into r squared into AR vector. What is the dl? dl equal to dr into AR value. Now you have to simplify this. You have to take the constant term Q divided by 4 pi epsilon naught into epsilon r. This is the constant term. You have to take it out. Then remaining is integral dr divided by r squared. Now you want to integrate this. You have to bring this term to the numerator. Therefore r power minus 2 into dr. Now what is this integration for this? So here is, that is, what is the formula for integrations? Integration of x power n into dx. What is the formula? Which is equal to x power n plus 1 divided by n plus 1. Yes. Therefore we are going to get, so instead of this n value we have minus 2. Therefore you are going to get r power minus 1 divided by, here is minus 1, which is equal to minus 1 by r. Clear? So this is a minus 1 by r here. Now you have to substitute the limit, this answer. Q divided by 4 pi epsilon naught into epsilon r minus 1 by rb plus 1 by ra. We know the formula for V. V equal to Q divided by 4 pi epsilon naught into epsilon r into r. Therefore V equal to VA minus VB. Now you want to find out the electric potential of an infinite line. You just consider this infinite line. This is the infinite line. which is lying on the z-axis. What are the things we are discussing in electric field intensity? The same concept is going to appear here also. You know the electric field intensity formula for an infinite length. So what is that formula? E equal to rho L divided by 2 pi epsilon into R into AR vector. In this formula, in electric field intensity, we are used H here because H is the distance. Here R is the distance. That's why we are using R. Now what is the DL? DL equal to DR into AR here. Now consider an infinite line charge which is lying on the z-axis with a uniform charge density of rho L in coulomb per meter. The point P is at radial distance RB while the point A is at radial distance at RA. Now the E due to the infinite line charge along the Z axis is known and is given by E is equal to rho L divided by 2 pi epsilon naught into R into AR vector. DL equal to DR into AR vector. Now we want to find out the VAB equal to minus integral RB to RA rho L divided by 2 pi epsilon naught R into AR into dr into AR. Now AR into AR which is equal to 1. Now RB to RA rho L divided by 2 pi epsilon naught into R into dr. Now rho L 2 pi epsilon naught is the constant. You can take it out. So what is the remaining thing? Dr and R. So you want to integrate for this term only, which is equal to ln R. Clear? Now you want to substitute the upper limit minus lower limit. So this is the things. So you know this logarithmic division formula. So using that formula we are writing this equations. Now the potential V for an infinite line is V equal to rho L divided by 2 pi epsilon naught ln RB by RA. Electric potential of circular disc. Just look this diagram. We are already discussed this concept. Okay. Here is the derivation is remains same up to the electric field intensity. Up to this the derivation is same. Please refer the previous video. Now you want to find out the electric potential V at a point P due to the charged disc. Now V equal to, what is the formula? V equal to integral E into dl. We know the formula V equal to minus integral E into dl. This is the formula for electric potential in integral form. Now V equal to minus integral E into dl. So this is a E. So instead of this dl we are dealing in dx directions. And the limit is, so this is the origin, the charge is may be located here, and surrounding this is a field line. Yes, so this is a part. We are moving this test charge against the field. Suppose if this distance is a maximum distance which is equal to d, then the limit is d to 0. Clear? Now you have to substitute this E value. It does not depends on x. Dx term is contributing the integral part. So you want to integrate only for this term. So what is the integration for this? Which is equal to x, and the limit is d to 0. Now substitute the limit, upper limit minus lower limit. So you are going to get d value. Again go to the figure. From the figure you want to find out the two things. One is the d value. Next you want to find out the cos alpha. Cos alpha equal to h by square root of h square plus r squared. D equal to square root of h square plus r squared. Now you want to substitute all the value here. This is the cos alpha, this is the d value. Now you take the LCM here. So this term going to become here, and this term come to the denominator. Now this one and this one is going to get cancelled. Therefore, V equal to rho S into square root of h squared plus r squared minus h divided by 2 epsilon. This is an electrical potential of circular disc. Thank you.